Hi, in this video, I will be showing you problem number 10 of chapter 15, section 5. Find the area of the surface given below. The part of the sphere x square plus y square plus z square equal to 4 that lies above the plane z equal to 1. So we have to consider the part of the sphere x square plus y square plus z square equal to 4 that lies above the plane z equal to 1. That is the only part we have to find out the area, surface area for. So before we get to that, what is the formula for surface area? Write an expression for the area of the surface with equation z equal to f of xy, where xy belongs to D. A of s, which is the area of the surface, is given by double integral over D, square root of partial derivative of f with respect to x at xy, the whole square, plus partial derivative of f with respect to y at xy, the whole square, plus 1 dA. The same formula with an alternate notation is area of S is double integral over D, square root of partial derivative of z with respect to x the whole square, plus partial derivative of z with respect to y the whole square, plus 1 dA. So we have the figure shown to explain this formula, and then this formula actually resembles the area of the arc length, which we did in Calculus 2 class, which is L equal to integral A to B square root of 1 plus dy by dx the whole square dx. Now, what is the surface, what is the domain of the surface? So the domain of the surface is obtained by substituting or finding the intersection of the surface with the plane z equal to 1. So that will be the domain over which we have to find out the area of the sphere. So let's look at the picture for this. So we have a sphere and it is cut off by the plane, horizontal plane z equal to 1. So note, in the picture, the intersection of the sphere and the plane, horizontal plane z equal to 1 is a disk. So let's apply the formula now. So step 1 is to find out the intersection algebraically. We know that it's a disk. We'll find out the equation of the domain. So substitute z equal to 1 into the sphere x square plus y square plus z square equal to 4. So the intersection of the sphere x square plus y square plus z square equal to 4 and the plane z equal to 1. Substitute z equal to 1 into the sphere, equation of the sphere. So we get x square plus y square plus 1 equal to 4, or x square plus y square equal to 3. So which is a circle with center at the origin, radius equal to square root of 3. But for the surface, the domain would be the disk, where the boundary is a circle. So the domain in xy form, domain for the area of the surface is D equal to all those xy such that x square plus y square is less than or equal to 3. Now let's get to step 2. That is to evaluate the area of the surface using that formula. evaluate the area of the surface. A of s is given by the formula double integral over d square root of f sub x square plus f sub y square plus 1 dA. So we are going to get the partial derivative of f with respect to x by solving z from the equation x square plus y square plus z square equal to 4. So from the equation of the sphere, z equal to square root of 4 minus x square minus y square. So we have to get the partial derivatives now for this f of xy or z. F sub x is partial derivative of z with respect to x, which is 1 over 2 square root of 4 minus x square minus y square, which is the outer derivative, times the inner derivative with respect to x, that will be negative 2x. So simplifying, we get negative x over square root of 4 minus x square minus y square. Similarly, f sub y or partial derivative of f with respect to y would be negative y over square root of 4 minus x square minus y square. So area of the surface, A of s, is denoted by double integral over d. F of x square is obtained by squaring this. F of y square would be obtained by squaring this, which would be x square over 4 minus x square minus y square, everything within the radical, plus y square over 4 minus x square minus y square plus 1 dA. Simplifying, we get double integral over d square root of x square plus y square plus 4 minus x square minus y square, all divided by 4 minus x square minus y square, everything within the radical, dA. Reducing, we get A of s equal to double integral over d 2 divided by square root of 4 minus x square minus y square dA. So here these two cancel out, x square and negative x square, y square and negative y square. So square root of 4 on the numerator, which is 2. So we'll call it step A. Then we will evaluate this because we are finding over the domain D, which is after all a disk. So converting to polar coordinates will minimize our computation for the integral. So changing to polar coordinates, the domain D in step 1 changes to all those d such that r comma theta, where 0 less than or equal to r less than or equal to square root of 3 and theta lies between 0 and 2 pi. So we get area of surface equal to theta integral theta running from 0 to 2 pi, r running from 0 through square root of 3, then 2 divided by square root of 4 minus r square, then dA changes to r dr d theta in polar coordinates. Obviously these two variables are separate here because both of them are have finite limits. So we can write this integral, one for theta, one for r. So it's A of s equal to integral theta running from 0 to 2 pi d theta, then times integral r varying from 0 to square root of 3, 2r over 4 square root of 4 minus r squared dr. The first integral value is just 2 pi. We'll call the second integral as I1, and then we'll evaluate I1 and come back to the step and substitute. We'll call it step C. So I1 is integral 0 to square root of 3, 2r over 4 minus r squared dr. So obviously the best method here is use sub. So substitute the expression within the radical as u. So u sub method would work. So 4 minus r square equal to u. So negative 2r dr equal to du. Then changing the limits correspondingly, r and u, r equal to 0 will give u equal to 4. R equal to square root of 3 would give u equal to 1. Substituting that new limits, so we get integral 4 through 1, then negative du over square root of u. Because of the negative, and by switching the limits, we can change the negative to positive. So it is u to the negative 1/2 du, which will become negative u to the positive 1/2 over 1/2 between the limits 1 to 4, between the limits 1 and 4. So we get that to be 2 times 2 minus 1, which is 2. So I1 equal to 2. So put this back into the step A of S. We get substituting this I1 into the expression for A of S in C. We get A of S, or area of surface, equal to 2 pi times 2, which is equal to 4 pi. Hope this video helps.